afternoon. Welcome to lesson 2.6. Yes, I said 2.6. We're skipping lesson 2.5. That's over mental math. We're going to go ahead and throw some of those into lessons to come. So we're just going to go ahead and go to 2.6. So there will be a gap in your lessons. There you go, 2.4 and now 2.6. Today what we're talking about is evaluating expressions. And we're here in the spirit shop. Figured that could help us out a little bit. We're going to do some problems in here and see what we can figure out. Before we get started though, we're going to go to the problem of the day. And from there, you're going to do your vocabulary section. So go ahead and get ready for those two. We've already learned how to represent unknown quantities with variables. Today what we're going to do is we're going to solve expressions with variables in them, but we're going to have a given value for the variable this time. So we're just going to substitute that in there for the variable. But before we get started, have you ever tried to find the value of something? Have you ever tried to just know about how much something is going to be? An example would be some chips, right? If I buy one bag of chips and it has a price next to it, if it's 75 cents, then that's how much I'm paying. I'm paying 75 cents. But what if I grab, because I'm super hungry, a bunch of chips, right? And I just set it down the counter. All right, how much are we paying here? I'm good to go. Here's $1.50, right? Is that going to cover this? No, right? So what we're doing is the variable is the unknown number. Once I figure out that variable, once I plug in that, then I can solve the expression and tell you how much I'm going to have to pay. Another example. I'm not going to be very happy with me. All right. What about, let's do another example. Animal crackers. No, animal crackers. Crispy treats. That's more speed, right? Okay. So let's say that these cost 50 cents, right? If I have one, I know the value of it. It's 50 cents. But what if I have an unknown number of Rice Krispie treats? How do I know how much I'm going to pay for these? What's the value of it? Well, it's going to be 50 cents times, we'll say R for Rice Krispie treats. So it's R50 or 50R, right? However many Rice Krispie treats we have times 50 cents. Well, it's technically 0.5, right? So 5 tenths, 50 cents times R. How many do I have? Well, I don't know. We'd have to count, right? But that's our unknown, however many I have. Once we have that unknown, we can plug it in and say, oh, Mr. Hall, you have 6 Rice Krispie treats. 6 times 50 cents is $3. You owe us $3. And another $1 for the 2 in your pocket, right? So, everywhere. So, Rice Krispie treats, chips. If you want to know how much you're going to be paying, you need to know your variables, how to plug them in and solve that expression. That's what we're getting into today. So, it's going to be awesome. Let's go. We're going to change gears a little bit. We're going to switch away from food and we're going to talk about sports cards. Okay? Let's say that each card that you're buying costs you 20 cents a card. Okay? So you have to pay 20 cents a card, but on top of how much you pay per card, no matter what, you have to pay 90 cents for the box. Okay? So it's 20 cents a card plus a flat rate of 90 cents per box. How much would you be paying? Okay? If you're solving that and doing that, you're going to figure out that it's $2.90. What if we said that there's 30 cards? Okay, so 20 cents a card times 30 cards plus the flat rate of 90 cents for the box. So every time it's 90 cents. But per card, we're paying 10 cents. So how are we going to figure stuff like that out? In our problem, we had a number that changed, right? What was different in the problem? Well, it was the number of cards that we had. It was either 10 or 30. So since that number can change, what is that called? What's a value that can change in a problem? Well, a couple lessons ago we talked about that's a variable, right? So we plug in a letter for that value if it's something that can be changing. So that's what we've discussed before. Let's see if we can write an expression with a variable to represent that problem. let's stop and think for a second before we write our full equation. What expression would show how much an unknown number of cards, which is going to be represented by x, costs? Well, if you remember, when we were first starting our problem, we know that a card costs 20 cents. So if we wanted to set up an expression that's going to show how much, however many cards we buy costs, it's going to be 20 times x, or 20x. But thinking about the original problem, is this going to show us the total cost? Well, no, it's not, because we haven't included that 90 cents charge for the box yet. Remember, we're buying cards at 20 cents a card, but we have to always pay 90 cents for the box itself. So what is the total cost of a box of cards? Well, we're going to have to add that 90 cents onto our original expression here, and we're going to end up with 20x plus 90. It's 20 cents per card. Do we know how many cards? Well, that could change, so we're leaving that a variable. So 20x plus 90, the cost of the box. So we could use our expression here to figure out the cost of however many cards we buy. So if we wanted to buy a box of 30 cards, we're just going to replace that x with 30, because x represents the number of cards. So once we evaluate that, we can just plug it in and go 20 times 30 plus 90. So what is the total cost of 30 cards? Well, it's going to be 690 cents, or $6.90. So this is what we're talking about when we are substituting into our expression for the variable to evaluate it. So here's what we're going to do before we jump into our guided practice section. We're going to do one more practice here just really quick, just to make sure that you have it down. So go ahead and copy this table into your PBIL. Go ahead and pause it if you need to. And so what this table is we're saying, I'm going to see if we can get them both in here. We are saying that we have the expression 3x plus 11. Well, and this line down here is telling us, okay, when x is 3, how much is this worth? When x is 5, how much is this worth? So remember, all we have to do is plug in the number that's given, substitute it for that variable. So let's look. If we were to do this one, it would be 3, because that's what we're starting with. 3 times what? Well, it's going to be 3 times 3. We know that that x is 3. We're going to plug that in. Plus 11. If we remember our order of operations, we have to do the multiplication part first. So 3 times 3 is 9. Plus 11 is going to be 20. So for this expression, when x is 3, the value is 20. Let's look at that next one. If we plug in 5 for x on this same problem, we have 3, not x anymore. We know it's a 5 plus 11. So see if you can solve that one, and then I'll give you the answer. It looked like we were paused, but we weren't. I was just holding it. All right, so here we go. 3 times 5 is, well, 15. 15 plus 11 is going to be 26. So hopefully you figured out that when, So hopefully you figured out when x is 5, the value of 3x plus 11 is 26. So that's what we're talking about with substitution. All we're doing is taking those expressions we made with the variables, and we're putting in numbers so we can solve it. So go ahead and flip to your guided practice section now. We'll do a few more problems. Back to the classroom, we're going to do a few guided practice problems together, and then I will send you on your way to your quiz, and then we will call that a lesson. So, let's look at our first practice problem here. We have t minus 8. That's our expression, short and sweet. Here it's telling us that t equals 18. So remember, when we substitute, we're going to take t, and now we know what the value is. The value of t is 18. So when t is 18, we're just going to substitute, make that 18 minus 8. What is 18? 10. So that's number 1. That's in your guided practice. Let's move on to number 2. For number 2, we're going to add one more step, just make it a little bit more complex. So here we go. We have 6w plus 9. We know that the value of w is going to be 3. So let's rewrite our problem with our new value. 6 instead of w, we know what it is. It's a 3 plus 9. So now all we have to do, remember the order of operations, we need to do the multiplication first. What is 6 times 3? Well, 6 times 3 is 18. If we rewrite the problem now, we have 18 plus 9. That's going to give us 27. So that's the answer to number 2. Make sure you write down each step in your guided practice, and we'll look at number 3. For number 3, we're going to put the variable in the expression twice this time. It's going to be the same variable, but we're going to use it twice. So let's look at what that looks like. Here we have 3z plus 4 minus 2z. We know that z equals 5. So every time we see a z, we're going to substitute 5 for it. So we have 3 times 5 plus 4 minus 2 times 5. So again, if we have the variable, we know that the variable is z. We're just going to plug it in or substitute it for the variable. Every time we see a z, it's now a 5. Now remember your order of operations. We can't just go straight down the line. We need to do our multiplication first in this instance. So 3 times 5 is 15. I'm done with that. Plus 4 minus 2 times 5 is 10. I'm done with that. Now we're at 15 plus 4 minus 10. Well, if you remember the order of operations again, it doesn't matter if we add or subtract first. We just have to do whatever is left to right now in this instance. So 15 plus 4 is 19. Minus 10, we're going to end up with an answer of 9. So hopefully that works for you as well, and you have this down in your guided practice. So now what I'm going to have you do is take your quiz online on Pearson SuccessNet. Go ahead, it's going to be out of 5 again. Put your score in the subject. Email me your score tonight, and I will see you in class tomorrow.